Hello students, today we are going to discuss a quadric surface hyperboloid of two sheets for third semester CBCS, and the paper name is Analytical Geometry. Its code is M80HC3036. Myself, Dr. Barnali Deka from Department of Mathematics, Darrang College. So we have already discussed hyperboloid of one sheet. Okay, now today we are going to discuss hyperboloid of two sheets. As we know, quadric surface is defined in space by an equation of the second degree in x, y and z. Okay, the graph of a quadric surface is often determined by tracing graphs in xy plane, yz plane and zx plane. To form a quadric surface, we have to put all these traces together. So let us discuss today a quadric surface hyperboloid of two sheets by using such type of equation, that is x square by a square minus y square by b square minus z square by c square equal to 1. But we have these type of equations also who represents hyperboloid of two sheets. Already this one I have told. So next one is, here we can notice that in hyperboloid of one sheet we have two positive signs before the second degree term and one negative term. But for hyperboloid of two sheets we have two negative signs and one positive signs before the second degree term. So here these are the two negative signs and here it is positive. In this case these are the two negative signs. This one is positive. In this case this one is negative and this one is negative, but this is positive. So all these three equations also represents hyperboloid of two sheet. Okay, so now we are going to try to draw the hyperboloid of two sheets. We are going to draw the hyperboloid of two sheets by using the three traces. Say, with the help of an example, let it be x square by 25 minus y square by 16 minus z square by 9 equal to 1. Let it be 1. Okay, so the first case we are going to trace this hyperboloid of two sheets on xy plane. So on xy plane z is 0. Therefore this equation 1 becomes x square by 25 minus y square by 16 equal to 1. Okay, definitely this equation represents a hyperbola. So where a is equal to plus minus 5 and b is equal to plus minus 4. So let us draw the graph. So this is the graph. Here it is x-axis and this one is y-axis. So we draw the rectangle so that we can find out the asymptotes by using these 4 points, plus 5 minus 5 and plus 4 minus 4. Okay, so using these 4 points we draw the rectangle here and its diagonals. These two diagonals represents the asymptotes for the hyperbola of this kind. But here a is bigger than b. A is 5 plus minus 5 and b is plus minus 4. So a is bigger than length of a is bigger than length of b. Therefore the curve opens up on the right and left side of x-axis. So we draw the curve like way. Here it is in 2D figure and we try to draw it in 3D figure. So it looks like this one. So this is the x-axis. Here we have only xy plane, that is this one, xy plane. Okay, this one is the xy plane. Okay, so then next we are going to draw the graph for xz plane. Okay, so trace on a xz plane where y is 0. On xz plane y is 0. So the equation becomes x square by 25 z square by 9 equal to 1. It also represents a hyperbola. So where a is equal to plus minus 5 and c is equal to plus minus 3. Okay, now we trace the graph like way as before. We draw the rectangle for using these 4 points plus minus 5 and plus minus 3, and then draw is diagonals. The diagonals represents the asymptotes for this rectangle, for this hyperbola. So since here also A is bigger than C, therefore the curve opens up the right and left hand side of x-axis, where 50 is 50 and minus 50 are the vertices for this hyperbola. Then this is the 3D figure. Okay. So next we try to find out this one. We try to draw this one is our 3D figure. Okay. Next we have another case, the trace of the graph in YZ plane, where in YZ plane x is 0. So the equation 1 becomes y square minus y square by 16 minus z square by 9 equal to 1. So we can write this one as plus y square by 16 plus z square by 9 equal to minus 1. Okay, which is not possible in real sense, because this figure is positive, this figure is also positive, and sum of these two figure cannot be negative. Sum of these two positive figure cannot be negative. So in real sense we cannot find any graph for this equation. Okay, now let us take, but if we consider x is equal to plus minus root over 50, where this is equal to plus minus 7.1 approximately. So the equation 1 becomes plus minus 50 whole square divided by 25, then minus y square by 16 minus z square by 9 equal to 1. So this means 50 by 25, that is 2. So it is y square by 16 minus z square by 9 equal to 1. So which can be written as y square by 16 plus z square by 9 equal to 2 minus 1 means 1. Okay. Now this equation represents an ellipse for x equal to plus minus 7.1. So the above equation represents, hence the above equation represents an ellipse, where here b is equal to plus minus 4 and c is equal to plus minus 3. So now we try to draw the graph for this ellipse. Okay, the graph of this ellipse like this one. It is YZ plane, this is YZ plane, and for YZ plane, for the 0 0 origin YZ plane, we draw the ellipse like well. It is 4 0 minus 4 0 from this point, and 0 plus 3, 0 minus 3, this one minor on minor axis, this one is on major axis, therefore this is the ellipse. So for 3D figure we get such type of figure. So it is 0 0, but we need to shift the x coordinate from 0 to plus 7.5, plus 7.1 and minus 7.1. This one is minus 7.1, and the point is plus 7.100, and this point is minus 7.500. So we get one ellipse here, one ellipse here for YZ plane. Okay, and we have already find out that for 500 and minus 500 vertices we get two hyperbola. Okay, so from this equation, from this graph, combining all these three cases, we can find out the figure like this one. Okay, so let me slide it so from beginning. Okay, this one like this one. Okay, and then here, though it is 4 4, this one is 4, but in our case it will be 5 here. The vertices will be minus 5 and here it will be plus 5. So slide this way. Okay, and this one, and this is the complete figure. Okay, within this region we cannot find any real graph. Okay, so this is known as such type of figures or surfaces are known as hyperboloid of two sheets. Okay, so if you have any doubt, please give your doubt in Google Classroom, my Google Classroom. Okay, so I think I wrap up my class for today, and thank you.